I'm Michael. Today we're going to make this live edge walnut slab table with a metal base using no welding and no planer. After our cutting board project, I had this slab left over and I thought that would make a great end table. Flipped it over and started to prepare the back side so that I could fill all the cracks and voids with resin. After taping it off with Tyvek tape, I prepared my work surface and got ready to pour some 2-to-1 total boat epoxy into all of the cracks and crevices on the face of the board. After I finished pouring, I hit it with a torch to get rid of any bubbles, and then I let it sit for a couple of hours to set up. While the resin cured, I set to making the 3D models for the joints for the legs. To do this, I'm using my iPad Pro with the Shaper 3D modeling program. It's very intuitive and lets you design like you would with a pen and paper. And I am going to go ahead and link in the description to the 3D files for this build. Feel free to use them in your own designs if you want to try something along these lines yourself. Once I had the design the way that I wanted, I prepared it to print using Cura and started it on our Artemis 300 3D printer. And I'm printing these out of Hatchbox PLA at 100% infill, so they'll be as strong as possible. All right, it's been sitting for about 24 hours, and now I'm just going to flip it over. We're going to look at the back, and we're going to see if anything else needs to be filled from the other side. And it looks like none of the resin leaked out of this side, and this side's going to need to be treated as well, but I think we're going to start by scraping off the top. And to clean this up, we're going to start by using our hand power planer. I started at 3/64th removal, and now I'm going to drop it down to 1/32. After using the hand planer, I switched to my angle grinder so that I could eliminate any lines that were left from the planer. I also used the angle grinder to soften the edges. Alright, so it's fairly flat now, and we're going to switch to the Orbital palm sander to finish it off. One of my final tricks when doing the final sanding is to put a light pencil coat on top of the piece so that when I'm sanding I can see what has already been sanded and what needs a little bit more. So the top is all rough sanded, and now we're going to flip it over and do the same on the sides and the back. And now it's time to mix up some total load epoxy so that we can fill the cracks on the back just like we did the cracks on the front. And there was one area that was fairly deep and wide, so I just made a little brace with the painter's tape. After filling the cracks, while that resin set up, I revisited my 3D printer. I'm not really sure what happened here, but it looks like the print had skipped at the very end. And on the top of all of these, it didn't fully adhere. So we'll just take them off and see if we can work with them still, and if not, then we will reprint them. This part came out as expected though, and now we just need to verify that the tube will indeed fit in the opening. All right, so both of these pieces split where it was too thin to actually be usable. So I'm gonna go ahead and reprint this part after verifying the size of the opening. And that will work after we clean it up with some sandpaper. So we're gonna go ahead and reprint those other parts, and these parts are keepers. So I quickly did up off camera a set of caps for the ends of the legs, because I realized that we had forgotten to do a hardware set to cap off those legs and protect the floors from the exposed pipe. And then I just repositioned these so that they'll be printing in a different orientation to see if that makes a difference in that print quality. All right, so the second print has just finished, and at first look, they are looking a lot better. So I think that we have usable parts here. After the resin set up, I set to removing the bulk of the excess with a paint scraper. I found that this is a great tool to take off a large volume quickly. After getting it down pretty much to the surface, I switched to my card scraper and then to my random orbital sander. There was one section of the slab that was a little bit too thin, and I was worried that it would break with use. So I traced a line using my pencil, trying to follow the organic shape of the living edge, and then trimmed it with my jigsaw. I then finished shaping it with my random orbital sander. And then it was time to plan where the legs were going to go. I used my drywall square to ensure that the components would be on perpendicular lines, so that the cross brace would line up properly when I got to installing that later on. I carefully marked the position of each bracket, and then I tried using a large Forstner bit to inset an area. This was a little bit more difficult than I expected it to be, so I had to try a couple of different things to make it so that I had a flat enough surface to get the bit started. I then used a smaller Forstner bit to hollow out some of the area so that I could then use the larger Forstner bit to finish it off. I wasn't super careful to get all of the insets at the same depth because I'm going to account for that when I cut the legs in the next step. After making the holes, I used a sanding pad on my multi-tool so that I could get into the tight inset of the recessed area. Ba-boom! It's ready. All right, so now we're just going to lightly clean any remaining dust off of the table. I'm going to do the whole thing. I'm not going to focus too much effort on the back because we're only going to be coating the top side with resin right now. We're just going to do that with a rag that is slightly dampened with paint thinner. And you can see how much we're getting off with this go around. So it's important to do this, otherwise it gets sealed in with the resin. And now we're just going to give that about 10-15 minutes to dry before we pour the final top coat of resin on the tabletop. Since we didn't put this through the planer, the tabletop is not necessarily level, and there might be a couple little dips from the sanding process. First thing that we're going to do is we're going to use shims to level the tabletop the best that we can, and then we're going to pour resin on top, just a thin coating so that it'll self-level and give us a nice smooth tabletop. All right, we have this pretty good. When you are leveling a big surface, it is important to rotate your level and check it at multiple spots, not just one. I'm going to mix up 12 ounces of epoxy. I'm using the Total Boat 2-to-1, so that's going to be 8 ounces of the epoxy and 4 ounces of the hardener. Using a foam brush, not a bristle brush, so that we won't get any bristles in the resin. I'm bringing it pretty much right to the edge, but I'm not going all the way to the edge because I don't want it to drip over the side. I'll come back at the end to smooth it out. It's okay if it drips over, but it'll make it so that there's less that I need to clean up at the end. The top overall came out great. There's one little air bubble, but I'm just going to leave that, and over time it'll naturally wear down. I like the high gloss finish, so I don't want to disturb that at this point. I'm just going to flip it over so that I can deal with the different drips that are along the side. And I'm just going to sand those down, and then it'll be time to finish the back. I'm going to start building the leg assembly, and for that I have 3 pieces of aluminum tubing that's 1.25 inches, and then I'm going to start by taking the 3D printed brackets and fastening them with some 5-minute epoxy to the bottom of each leg. So we're ready to mark the heights of our legs, and what we're gonna do is these holes are not the same depth because of how the piece of wood was. So these legs are all gonna have a slightly different height. So what I made is we made just a quick little jig here. That is level to the ground so that we can hold it up to each leg while it is in place to mark the height, and then we will get a uniform height for each leg. Now we're just going to use a standard pipe cutter to cut the aluminum tubing to the height that we just marked. I designed the fittings to have a pretty tight tolerance, so they don't need any epoxy or anything like that. I just used a rubber mallet to tap them down to the registration marks that we had made earlier, and then I did a final alignment using the bottom side of the legs, not the side with the bracket, because that was the side that was going to have an equal distance when the project was done. I then set to positioning the rest of the assembly and putting the crossbars in place. And again, a link to all of these 3D printed files will be in the description below, so feel free to check those out and download and print if you want to use them in one of your projects. And keep in mind that you can use different combinations of all of these brackets for different shaped tables as long as you're using the same size pipe. And after I got all that together, it was time to be done for the night, so I flipped the top back over and I put a nice heavy coating of high gloss varnish on the backside so that it would blend with the high gloss finish of the resin. Alright, so right now it's looking a little bit like a medical device, but once we paint it all a uniform matte black, I think it's going to look fantastic. Off camera, I just did a light sand of the 3D printed parts and the aluminum, cleaned it up with paint thinner real quick, and now it's time to paint. Alright, this now has 4 coats of varnish on it, and now it's time to put the legs on. And since the table was so narrow, it was a little bit wobbly with the feet that we designed, so I did design a different foot for the front to help stabilize it, and I will also link that in the file with the other fittings. Overall, this table came out great. The techniques that we utilized with the 3D printed brackets made it so that we didn't need to use a welder. The resin surface gave us a nice level finish, high strength, high durability without needing to use a planer. And I think that these are all techniques that we'll be able to use in future projects. If you found any of this video helpful, don't forget to subscribe.